Hello everyone. So I will show you how to do a deep learning classification from data from our engine. First, I'm using Landsat composite, cloud masking, etc. The same as usual. And then after that, I create index image, to add as a variables. I also add elevation too. And after that I sample the land cover based on the image, distribution. As we zoom in, this build up. Blue is water, green is shrub, I think shrub, and there is dry shrub, wet shrub, herbaceous are sample of data. You can see the data itself by the link later. After that, I split the data to training and testing. Then I extract the samples, extract the Landsat image value and indexes. After that, I will export the image and the test data, and no, the sample data to my drive on where I will use it as a training on land cover classification in TensorFlow. I'm using Colab, so make sure you have Colab, right? Okay, Colab, and have sent you the link of the script later. Okay, after you run the code, you get how many sample size, how many test size. I will export the data, put the image and the samples. You can wait this for a little while. It's gonna take a while, so be patient. If it's done, we will continue. Okay, I think it's done. I already export the image and samples. So you go to the Collab. So you have to create a Collab script. I hope you understand how. First, we need to install some packages. I use a raster and RPA to read the T file or Landsat images file, and RPA to plot the image. So much better. Then after that, I import some packages. Like pandas, numpy, keras. Keras is for the deep learning, and rasterio, yeah, is there for the to read the T file. And I use some scikit-learn data such as convolution metric, convolution display, and question report to see the assessment. I use matplotlib, to plot the some like the process of the what do you call it? The process of learning, etc. And also matplotlib colors for legend, for our data legend. Okay, it's in there. I already installed the package. If we're done, we can continue to the importing the packages. Okay, it's importing. Then after that, this is important. You need to mount Google Drive. So we export the data to Google Drive, right? So data is supposed to be in there, right? So let me check our data in the drive. Is it already there? Okay, you need to connect to Google Drive so that we can access the data. Takes a while. Use allow. Let me check it. See, this folder is already the Landsat image and the samples in CSV. Okay, there this is the parameter, like how many features that we use, the class value, and how we split the sample to train test using samples column. The number class is 9, and the class is 1, 2, 3, 4, 9, and this is the palette, the color for legend, and this is the path of the image and the path of the sample. Okay, we got it. Then let's try to load the image first, if we can load the image at all. Okay, I'm using 654 composite. Band 6 is where, band 5 is near, and band 4 is the red band. So this image is correct. Okay, let's read the sample path 2. After we read it, I'll try to shuffle the data, so that the data is mixed. So not only from the same classes in a row, so different class and some row. After that, I try to split the data, split data from the train to test based on the column, this column here. I try to split it, train and test, and then I also try to take the features only, which is this band 1 until elevation. We'll classify this for label. After that, I try to receive the array, so that it can fit with our model. Then yeah, that's what I do. Make sure the data frame or from the pandas, we read from the pandas, right? We turn into numpy array so that it can be by the Keras model. Then for the output, which is the label, I'm using two categorical packages from Keras, to switch to make the data to one hot encoded data, for the label. Okay, let's run the data. Okay, it's done. This is our data shape. This is the model we use. It's very simple model with 64 neuron. 64, based on the what do you call it, group. So for the kernel, using only three by three windows, and the pool for max pooling. Actually, I don't use pooling, so I use it. Okay. So this is the input shape. So you input the model, blah blah blah. This is the model I made. I can make your own model, but this is my version. If we run it, we can see what the form of the model. Start with the input and then convolution one dimension. Why I use convolution one dimension? Because the data is mostly. Let me zoom the data first. Because the data is basically only one dimension. So we only reduce from the features one. Not we don't have spatial dimension here. So that's why I use one dimension kernel. That's why. So we create the model, this model, then we train the model. I'm using Adam optimizers because I think it's the best. It's very adaptive. Then loss category metric is accuracy. I use error stopping. So if the loss is getting higher, I will drop it. Okay, well, let's fit the model. It's gonna take a while. Yeah, it's gonna take a while. So yeah, be patient, I guess. Maybe we could increase the number of samples. Let's check the RAM usage. We can still use more. I think we should use more. I'm gonna cancel the training. I'm gonna do it again from the model. Then maybe increase the number of samples to be trained, the batch, to make it faster. I hope. Okay, it's loading. Takes time. Yeah, it's training. Yeah, be patient, I guess. It's gonna take a while. I mean, I use quite a lot of sample. If you see in the batch, in this part, I use like 14,000 batch size. So like this is quite a lot. Okay, maybe just wait for be patient for the data for the training to be done. It's gonna take well. I'm gonna pause it until it's done. Okay, I think our model is already done training. Okay, let's try see the progress from with the bar. It's quite sharp. It's quite bad. It's okay. Let's try. Let's try to apply the model to our prediction. How good? Distribution. Oh, there's some was is good. There's some was is quite bad. I think class 5 is the 6th value. What's the 6th value here? I think 6 is supposed to be the 987 dry shrub. I think dry shrub is I think it's common. Now let's try to apply the model. Okay, apply the model. So we classify the model. Yeah, it may take a while to apply the model. Okay, we can wait. Yeah, okay, we can create now a more simple model to see if there is a difference. It's gonna take a while. Okay, I think it's done. Predicting the data. It's take quite a while, I guess. Maybe our model is too complex. I think we need to make the model more simple later. That's okay. So we can try this data. Why is it take so long? Okay, it's done. So this is the result. Yeah, I mean it's not that good. I mean if we compare, we compare it to our the forest model here. I also create the model for the forest. Let's check the results, the difference. It's 70% accuracy. I think it's quite the same. You see the results. we're gonna compare it with the random forest model too. I think the forest model is quite generalized data, but our learning is to, we call it hectic. No, it's more like to the point, like something like that. This data, this the network is quite different. So KMM is our model, and after that you're done, you can save the data using here, the script. So I will save it in my drive. So let me check here. So data right there. Probably not. Take a while. Again, reload again. Yeah, it's still not. Here, done right. You can load the data. It's take a while. To 27 megabyte. So you can check in your QGIS. Okay, let's see. Let's open QGIS. Okay, I think it's already open. You drop it here. This is the results. Classification. Let's try to symbolize it using and then palette unique value specified. The result. I think this color is quite bad. Okay, the 9 is the condition forest, so dark green. There is palm oil. Let's try oranges. 7 is wet shrub, so let's use this color. 6 is shrub, so let's try a bit green. Then 5 is herbaceous, I guess, like green, yes. Then the 4th is the wetland, so you use teal color. Teal. Then 3 is water. Water is this color is quite good. Then number 2 is the wetland. Let's use this color. This width up and this maybe the city to 0. Hey, this result. Oh, that's the classification. This thing is quite good actually from my view. The put up the palm oil plantation, some shrub, and this wetland, wet shrub, and wetland. Yeah, it's quite good from my opinion. But there's some description here, like it's supposed to be barren, but it was like built up. Yeah, okay, that's it. I guess maybe yeah, you need to redo the model. Try to make a better sample or do something. Okay, this is my 2 cents. Thank you, and use good luck for you. So you can train a deep learning model through using your engine data. I guess that's it. Thank you. Bye bye.